Hello everyone, and welcome to our last video in my ratios and rates topic. Now in this video, we are going to be looking at what we call distance time graphs. Now these are graphs on a XY grid, like we're used to hopefully by now from linear relationships. And hopefully if you're looking at this in year 8, you would have seen these a type of graph and these two axes like you'll see in the example below. This isn't the first time you've seen those, hopefully. And I'll talk about this at length. And let's just jump straight into a question here. Now, sorry, not so much a question, but this is an example of a distance and time graph. Now, on my horizontal axis, or my x-axis, if you like to call it that, I have the time taken. So this is the time from, say, 0 all the way up to whatever time. So as I go along my axis here, time is passing, right? From left to right, time is passing. Now, up here is my distance traveled. So this is how far I'm going, for example. And you can see once again, my distance traveled starts at 0. And as I go up here, I'm traveling a certain distance, right? So I'm basically showing everything that we talked about relating speed to distance and time, but I'm showing a graph that tracks the movement of something and the speed of one thing. Now that in this example is a train journey, but main takeaway so far that I want to get at is that we start at 0 in this corner here, and as I go up, I'm traveling an increasing distance. As I go horizontally, time is passing, right? More time and more time is passing. Now, let's look at a couple of different parts of this particular graph. Now, looking at this, I can see a few interesting parts here. Now, I'm going to highlight a couple of these. I have some slopey bits here, here, and here. Now, let's actually ask ourselves, I don't want to even get into any crazy definitions. Let's just observe what's happening here. Well, we can see, for example, in this first one, that between, say, this point and this point, time has passed and we've traveled a certain distance. And in fact, we're traveling at this little highlighted bit, we're going to be traveling at some type of speed, right? Because we've driven a distance over a period of time. We've traveled a certain amount of distance per hours or per minutes. So here, I can say there's a movement happening, right? I'm kind of constantly moving up here. The same can be said from here to here. And also from here to here. Because my distance traveled is increasing and time is passing. So I have two elements here. I have a distance per unit of time. So I'm traveling at some type of constant speed here. So I can say here, I'm traveling, we have a constant speed or there's constant movement happening. My train is driving a certain amount of kilometers or meters over a certain amount of time. Now, what's happening in these sections? Because these two look a little different. Say from here to here, here to here, and here to up here. Well, let's actually look what's happening here. Well, let's look at what's changing, right? Because that's what gives us an idea about the type of speed from these distance time graphs. I can see that time's moving, right? Because I'm going in a horizontal direction. So say from this point to this point, I've moved, like my time has changed, but has my distance changed? Well, it actually hasn't, right? Because I've gone from left to right here. I've moved on my horizontal part of my graph, but I haven't gone up. I have just gone perfectly horizontal. So what that tells me, if my graph isn't actually increasing in the upwards direction, well, this tells me there's no actual distance traveled. Time has passed, but I haven't moved. Now, what do you think's happening there? Have a think. Well, to me, I'm sitting in this chair right now talking to you guys. Time is passing, but I haven't moved. So I'm actually still. I'm at rest. I haven't moved. What's my speed? Well, it's just zero, right? I've traveled 0 kilometers, and no matter how much time's passed, I just haven't moved, right? I'm traveling 0 kilometers an hour or meters per second. It doesn't really matter what unit we use, but we have a special word for this. And when we're not moving, so for example, here, here, and here, we are what we call at rest. So we're not constantly moving, we're actually still because time has passed and distance hasn't changed. Now, each of these little portions of my graph shows me whether the object is moving or at rest. These are the main two ideas that we're looking at here. But let me actually draw another graph, and I want to give you some more information and see kind of what we can pull out of here. If there's anything extra we can get from these next two graphs that I'm going to draw. Now, hopefully I'll draw these well, but I have my first one. It's my distance and my time. And here I'm going to do this particular thing here, and then I'm at rest, and then I go back down. And on this graph, I have my distance, I have my time. Here I've gone like this, and I come back down. And I want to compare these two graphs here. Now, they're both trying to communicate the same things to me. They're telling me that they're pretty much tracing out some motion of an object. Now, this can be a train, for example, like we had here. So this graph simulated a train journey, right? Because we moved, then we stopped at one stop. Then we moved, we stopped. We moved and we stopped. This would be like a good visual representation of how a train journey might go. Now, these here, I want to try to pull out some bits of information from these. And the two particular bits I want to focus on and compare is this part of this graph and this part of this graph. Now, if you were to just look at this with a naked eye, you'd be able to tell me just by observing. I don't need you to tell me anything about speed or distance, whatever, but we can say that this line on the right-hand side that I've highlighted in orange, that is a lot steeper than the one on the left. Hopefully we can agree to that. But you can see my one on the right, let's do these in different colors. My one on the right is a lot steeper than my one on the left. Now let's see what this actually means through the context of distance, time, and ultimately speed. So let's look at the right-hand graph first. So this thing here tells me I have traveled a bigger distance You can hopefully see that here. When I compare my pink to my orange it goes a lot higher vertically. So it's traveled a longer distance, and it's actually done this in a shorter amount of time. Because if we compare, for example, from here to here, that's a shorter distance, it's a shorter time compared to from here to here. So the motion that I'm drawing on the right, the slope actually tells me, by it being steeper, this tells me I've traveled a bigger distance in shorter time. And this one on the left, well, I have traveled a shorter distance, when compared to the one on the right, shorter distance in longer time. Now, what does that mean in relation to speed, right? Because when I go fast, right? If I'm driving my car really quickly, I'm covering a big distance in a shorter amount of time. Now, imagine, for example, if I were to race a car, right? If I were to run or even ride a bicycle and I were to race a car, right? The car is going to travel a lot further in a short amount of time. Whereas me on my bike or running, I'm going to go not so far, and it's actually going to take me a pretty long time. Or if we even compared us getting to the same point, traveling a certain distance, the car's going to get there in a shorter amount of time. Now, this brings us to the last takeaway from these graphs. And hopefully this is giving you an intuitive sense of how to work through this. The graph on the right would probably resemble, for example, a car. Because this portion here of the graph, I'm covering a big distance in a short amount of time. Now, what does this horizontal line again mean? Well, that means we are stationary. We haven't moved. And this part here, similarly in this graph, I have traveled some distance, not as long. It's taken me a longer amount of time. So what can we say about my speed? Well, we can say my speed is slower in the graph on the left. So let's say this was, for example, cycling. And this brings us to the last, as I said before, key idea here. So the steepness of the graph of the segments of the graph, the steepness of segments in graph tell us about the speed, right? Because speed just relates distance to time taken. And what are the two key takeaways? Well, a bigger slope, so a sharper slope, let's write that. So a sharper slope, say this one on the right, that indicates that I'm going quicker because I've traveled a bigger distance in a smaller amount of time. Speed is just distance dividing by time. If I divide a big number by a small number, I'm going to get a big speed, right? Dividing a big distance by a short amount of time gives me a large speed. So a steep distance time graph tells me, and one with a sharper slope tells me the speed is faster. And a more gentle slope, one that's not as steep, a gentle slope, well, that tells me that my speed is, what do you reckon? I'm traveling not so far in a longer amount of time. Well, if I divide that distance by time, it's going to give me a smaller number. It's going to give me a smaller speed. So a gentle slope means that my speed is slower. And that is how we can read and interpret my distance time graphs. And the bits we talked about was the steepness of the segments. They tell us how fast something's traveling. And the bits where it's flat or horizontal, like we said here, that tells us that we are at rest. We are not moving because time is passing and we're not traveling any distance. But thank you so much for watching, guys. This brings us to the end of ratios and rates. Thank you for joining me in these videos, and I will see you in the next series.